Alright, hey guys, we are working on quadratics. We are solving them. In 10.1, you solve them by graphing, and you learned that the solutions are also called the zeros, or the roots, or the x-intercepts. It's basically where the graph of the line crosses the x-axis. That's what we were looking for. And we're going to learn more ways to solve them in the rest of the chapter. The second way here is going to be by factoring. Now, as much as you may not have liked factoring when we were in the factoring unit, factoring does not go away. You always need to be able to factor in all the rest of your math classes. We use it for many different things, and probably the biggest thing we use it for is solving quadratics. So of all the ways we learn, it ends up being that students like this way the best. So get on that factoring. All right. Example 1, solved by factoring. You can see that this is a quadratic because it has a variable to the second power. Here's some tips. Make sure the squared term is positive. Well, the squared term is positive, but we can't factor in this order, right? In order to factor, we need to have it in what we call standard form. And standard form means that you want to have your highest exponent and then put them in decreasing order. So you want it to look something like ax squared plus bx plus c. Well, to do that, we have to decide, should we move this over there or should we move those over here? And that's why we have tip 1, the first tip. Make sure the squared term is positive. If I move this over here, I'm going to have to do it by subtraction, and then it's going to be negative. So instead of moving that over, let's move these terms over. So that means we would have to add 3 on both sides, and we would have to subtract 4n. And we can do that all at once. So we want n squared to be our first term, your negative 4n to come first, or next, and then plus 3 at the end. Okay, and because we've moved everything off of that side, we're now equal to 0. This is in the ax squared plus bx plus c format, except for it's an squared plus bn plus c. Okay. Then it says remember to use the zero product property. Zero product property is some fancy term, fancy little name of a property that says if you have two things that are being multiplied and it is equal to 0. So 0 because of the zero, product because that means multiplication. If you have this, then you can break it into a equals 0 or b equals 0. So essentially you can break it up and set each factor equal to 0. Our factors are probably not going to be single things. They're probably going to be things in parentheses. So we would set the whole factor, whatever it is, equal to 0, and that whole factor equal to 0, and then we can solve. Okay, so let me show you what that looks like. So first, let's just look at it just like we have done every other factoring problem. So just looking at this part right here. Okay, so we've set it equal to 0, and then we're ignoring the equals 0. We're just looking at the stuff before the equal sign. How can we factor this? Well, there are 3 terms. First of all, rewind. What are you supposed to start every factoring problem with? The GCF, right? Is there a GCF here? No. There's nothing in common in all 3 terms. So then we decide there are 3 terms. 3 terms get factored by AC method. AC here is 3. 1 times 3 is 3. So we have to find 2 numbers that will multiply to 3 that add to your B, which is negative 4. Well, the only things that multiply to 3 are 1 and 3. And in order to get a positive 3 when we multiply and a negative 4 when we add, they would both have to be negative. Then I'm going to recognize that this A is 1, and when A is 1, I can take the shortcut. So I don't have to go through the whole process. I can go directly to my parentheses. N minus 1 and N minus 3. Okay, so now I have completely factored that. I'm just going to drop down my equal 0, and I'm going to use zero product property. So I now have this split up as 2 things that are being multiplied. This is my A, this is my B. So that means I can take my first factor n minus 1, set it equal to 0, and then take my second factor, n minus 3, and set it equal to 0. And then I'm just going to solve each of these equations individually. Okay, so add 1. And now we have n by itself, and we get that n equals 1. Over here, we're going to add 3. And we get n by itself, and n equals 3. So we have 2 solutions. Is it okay to have 2 solutions when you solve a quadratic? Absolutely. You might get 2 solutions, 1 solution, or no solutions. Those are all possible options. How do you check them? You plug them back in. So if I'm checking this, I plug in 1 here. 1 squared is 1. Over here, I would get negative 3 plus 4 times 1 is 4. Negative 3 plus 4 is 1. So that checked. Checking it with the 3, 3 squared is 9. Negative 3 plus 4 times 3 is 12. Negative 3 plus 12, sure enough, that is 9. That checks as well. So we get 2 solutions. Okay, the zero product property is very important because sometimes students will try to solve when it looks like maybe this. Okay, the only number that you can be equal to split these up is 0. None of that works. It has to be a 0 that you're equal to over here. It's the only way it will work. Okay, let's try another one. The first thing we need to do is we need to get it in the form to be able to solve it, to be able to factor it. And that means what I was just saying, it has to be equal to what? It has to be equal to 0. So we're going to move either this over or this stuff over. We have to get everything on one side. But whatever your x squared, or in this case a squared term is, you want that to be positive. It will make it so much easier to factor. So because this is already positive, we don't want to move it, because if we move it to the other side, it would turn negative. So instead, we'll move the 5. Now, negative 5 is not like terms with anything that's over there, so we just tack it on at the end. Make sure you are in ax squared plus bx plus c format equals 0. Then you are ready to factor. Is there a GCF in all the terms? No. There are 3 terms, so it is AC method. It doesn't have to be AC method. Most of these ones will be, but it does not have to be. AC here is negative 35. We need to multiply to negative 35. We need to add to 2. 7 and 5 are the numbers that do that. It has to be 7 and negative 5. Can we take the shortcut here? No. So that means we have to replace 2a with our 2 numbers, 7a and negative 5a. Okay, so where did this stuff come from? It came from right here, and I simply added the a variable on the ends of them. Okay. Then why do we do that? Because now we have 1, 2, 3, 4 terms, and we know when there's 4 terms, we can factor by grouping. The GCF in this first half is 7a. Take that out. That leaves you with a plus, oh wait, here's 7a. I took 7a out. All that's left is a 1. Make sure you put the 1. You can't leave it empty. In the back, I see a GCF of 5, but looking ahead, I know in my parentheses I need a plus 1 in order for these to match, and the only way for me to get a plus 1 is if I pull out the negative sign as well. Okay? The goal when you're doing factor by grouping is for your parentheses to match. If they don't, then you're in trouble. It doesn't work. Because these do match, I can factor out a plus 1, and once I get rid of those, all that's left is 7a minus 5. I have now completely factored, and I am now ready to do zero product property, which means I'm just going to take a plus 1 and set it equal to 0, and 7a minus 5 and set it equal to 0. To solve, I subtract 1 here. A equals negative 1. Now this is a completely different problem to solve. I need to add 5. And then to get a by itself here, I'm going to divide by 7. So my 2 answers, negative 1 and 5 over 7. Please make sure when you are working these by yourself, you check your answers. It takes you 2 seconds in your calculator to type these in. Plug -1 in, see if it works. Then plug in 5/7, see if it works. Okay, example 3, find the zeros of the function or polynomial. What does that mean? Well, what are zeros? Zeros are the same thing as roots, which are the exact same thing as solutions, which are the same thing as x-intercepts. These all mean the same thing. Okay, so these directions are no different, oh my goodness, no different than saying solve. Okay, so they might say find the roots, they might say find the x-intercepts, find the solutions, find the roots, solve, whatever. It's all the same thing. Now this might look a little different because here we have some function notation. We're not just equal to 0 like we were, or just a problem like we were before. It doesn't matter. It doesn't matter if this says h of x, f of x, y equals, or 0. It's all the same thing. We're just going to act as if it says, as if that's a 0. Okay? It all means the same thing. So that means essentially what we are doing is we are solving this problem. It is already in ax plus bx plus ax squared plus bx plus c form, and your a is positive, so you are set and ready to go. So is there GCF in all the terms? No. What is the AC then? Since we're doing AC method, it's 15. What multiplies to 15 and adds to -2? 5 and 3, what do your signs need to be? -5, +3. Can we take the shortcut? No, because this is not a 1, it's a 3. That's okay. We can still do it. We are just going to have to take our -2x out and replace it with these. Remember, it doesn't matter what order you put these in, it will work out. So I could have put plus 3x minus 5x, it would still be fine. You'd have a little bit of different work, but your answer at the end would be the same. The reason we can do that is because -5x plus 3x is still equal to -2x. So we have not changed our problem. We've just now made it have 4 terms, which is convenient because then we can do factor by grouping. The GCF in the first half, all there is an x. So we take that out. We're left with 3x minus 5. In the back, oops, hold on, look at this. Look at what I did. This -5 became a +5. It should not be a +5, so let's fix that. Before we go any farther, we're going to run into a problem. Okay, so I just copied that sign down wrong. Now in the back, there is no GCF between 3x and -5, but that's okay because look at what our parentheses are. Now I can't just write 3x minus 5, or this won't work out. What I need to write is still the GCF, but it's just a 1. That's the only thing 3x and -5 have in common. Okay, but now that I have it in the right format, I can see that my parentheses of 3x minus 5 match, so I can factor those out. And what's left is just x plus 1. I've now completely factored it. So I set each factor equal to 0. And then we're going to solve. Here we add 5. And then we divide by 3. X equals 5/3. Here we subtract 1. X equals -1. 2 solutions. Please make sure that when you are working on your own, you plug each one in and you check your problem. Okay. If you were to plug these ones in, you would expect it to be equal to 0 because remember that h of x, or if it said y equals or f of x, that basically is a 0 for our purposes. All right, let's do one more together. Find the zeros of this polynomial function. Is it set up right? Sure. Ax squared plus bx plus c equals 0. A is positive. We're good to go. Is there a GCF in all the terms? No. How many terms are there? 3. So AC is -24. What multiplies to -24 and adds to 5? I'm not sure. Let's see. Do 1 and 24 work? No. 2 and 12? No. 3 and 8? Oh, maybe if I subtracted them. How would I need to subtract them? I'd need my 8 to be a negative and my 3 to be a positive to get the -5. In this case, whoops, let me change that to a 0 to make it easier for us. In this case, I can take the shortcut because my coefficient of x squared, my a, is 1. So I can go straight into my parentheses, x plus 3 and x minus 8. If you don't recognize that you can take the shortcut, by all means, go through all the steps. It'll be fine. You'll still end up right there. But if you see the shortcut, it'll save you some time. Once it's factored, set each factor equal to 0, and then solve. X equals -3. X equals 8. Check them, make sure they work. Both of these will. All right, your turn. Pause this video. Do these two problems. Keep in mind, these directions mean the exact same thing. Pause the video now. Okay, check your answers, compare them to mine. On the first one, we did some AC method. Our numbers were a -10 and -1. Plug those in, did the whole shebang here, and got 5 and 1/2 as our answers. On the second one, again, I did AC method. It took me a minute to find the numbers, but they are -3 and 16. If you don't find those, you cannot give up. Go through every factor. 1 times what is 48? Does that work? 2 times what is 48? Does that work? And keep going until you find it. In this case, it was only the third factor. It's just not one that we maybe would commonly think of to use. In this case, I did take the shortcut, and then I solved to get my 2 answers. Now keep in mind, what are we doing here? We are finding where these cross the x-axis. So that means if I were to graph this, here's 3, here's -16. If I were to graph this parabola, it's going to look something like that. So it is crossing at 3 and at -16. That is what you are finding. Don't forget about that. Okay, so besides plugging these answers in and checking them, what's another way you could check your answer? You could solve it by graphing. You could check it in your calculator with your graphing calculator and make sure that is in fact where they're crossing. Okay. All right, go ahead and keep working.